Hey Ryan, how you doing?
Oh, hey, yeah, doing well.
So I thought I'd bug you a little bit more. Last time we were talking about kind of where Iceberg came from. But we didn't quite get to how the table format is really related to those things and how you solve those problems. I was hoping maybe you could spend a few more minutes and kind of hit me with that.
Yeah, we get that question all the time, sort of like what exactly is a table format? Because most people understand what a file format is. And in fact, that was a very confusing piece a few years ago, before people were thinking about table formats. So a table format is kind of like a file format. A table format is how you keep track of what files are actually in your table, and most importantly, what is in those files. How do we skip through it more effectively? So you can imagine an analogy to Parquet, where you keep track of chunks of rows and you keep track of stats for those rows so that you can figure out which ones have the data that you need. Well,
Mhm.
at a higher level, what we're doing is just keeping track of a set of Parquet files and trying to figure out which Parquet files have the data that you need.
Okay.
Hive did the same sort of thing using directories, but like we talked about last time, directories introduced this correctness issue because you have to list a directory as a partition to figure out what's in it. So
Right.
Iceberg sort of takes all of that information, what is in each partition, along with more information about what's in each file, the sort of column ranges, min-max stats, and so on, and puts those all into data files that we can scan really quickly to figure out what data you need for a query. And then we can make changes to those data files rather than relying on puts or gets from S3 to actually change what's in the table. And that's how we get both atomicity, the better performance from better filtering, and so on.
Oh, okay. Excellent. I think that gives me a good background for that. Thanks.
No problem.